Hello everyone, I am Havish Patel. In today's video, we are going to understand a key concept in deep learning, multi-layer backward propagation in machine learning. The technique is at the core of how neural networks learn. The topic is presented by me, Havish Patel, and the goal is to grab how gradient flow in deep learning network to help modern learn more efficiently. Next, introduction. Backward propagation is the backbone of learning in deep neural network. But what does it mean? When a neural network makes a prediction that usually some error or difference between the predicted output and the actual result, backward propagation is the algorithm that tells the new network how to adjust its internal parameter called weight. To reduce this error, it does this by using a method called gradient descent, which will explain in upcoming slides. Multilayer neural network. A deep neural network is called deep because has multi hidden layers between the input and output. Here's how it works. The input layer take in a raw data, then come one more hidden layer which perform complex transformation on the data. Finally, the output layer gives as the result a prediction or classification. Each hidden layer learns to extract increasingly abstract feature from the data, for example, in an image of a face. The first layer may detect edges. The second layer may identify shape and eye or nose. The third layer may recognize full facial features. Next, forward pass overview. Before we understand backward propagation, let's first understand the forward pass. For a quick revision, which is the first half of the learning process. In the first in the forward pass, data flow from input to output layer by layer. Each neuron performs calculation using weight, bias, and activation functions like sigmoid. After all layers process the data, the final output is produced. This output is then compared to the actual value and the error or difference is calculated. Think of this all the prediction steps the modern tries is best to guess and then we measure how far off it was. Next, loss function. Now that we have an error, we need a way to measure how bad the prediction was. That's where the loss function comes in. A loss function qualifies the prediction error. The smaller the loss, the better the modern prediction. Let's look at some common types of loss prediction. First, mean square error MSE used in regression process. It calculates the average of the square difference between predicted and actual value. Cross entropy loss, mostly used in classification problems. It measures the difference between two probability distribution, the predicted output and the actual class. The goal is to minimize the loss prediction during training. A lower loss mean better modern performance. Now let's see what is back propagation in actual. Now we get to the heart of the meaning process, that is back propagation. After the loss is computed during the forward pass, back propagation kicks in to improve the model. Here's what it does: it sends the error backward towards the network layer by layer. It calculates gradient for the loss function with respect to each weight using the chain rule from calculus. Then uses the gradient to upgrade the weight, usually via a method called gradient descent. This is how the network learns by gradiently uh, its internal parameter to make better prediction over time. Next, step by step back propagation. Now, let's break down back propagation into simple steps so you can clearly understand how it works inside a neural network. First, compute output error. First, the network compare the predicted output to the actual label and calculate the error. Second one, calculate gradient with respect to each weight. Using calculus, especially the chain rule, we calculate how much each weight contribute to the total error. Third, propagate error backward. The error is sent backward through the network from the output layer to the input layer. Fourth, update weight using gradient descent. Finally, the modern update each weight to reduce the error in the next iteration. These steps are repeated many times over thousands of inputs. That's how a neural network learn and improve. Next, gradient descent formula. To understand how weight are update update during training, let's look at the gradient descent formula. Weight update rule is equals to W is equals to W minus N. Gradient descent formula. To understand how weight are updated during training, let's look at the gradient descent formula. What do this term mean? W indicates the current weight, N means eta, the learning rate, a small constant that controls how big the weight update. Do L slash do W. The gradient of the loss with respect to the weight, how much the loss changes when the weight changes. This formula tells us if the loss is high and weight is responsible, it then adjusts the weight in the direction that reduces the loss. This how the network becomes smarter with each iteration. Next, layer-wise gradient flow. Finally, let's understand how the gradient flow through the layer in a deep neural network. During backpropagation, each layer receives gradient value from the layer after it. These gradients are used to adjust the weight at the current layer. The process continues backward through the network all the way to the first hidden layers. Think of it like passing correcting signals backward through each layers. Help each part of the network learn how it contributed to the error and what it can do better next time. Next, activ- activation function and derivatives. Before gradient can flow backward, there's one more key gradient in neural network: activation function. This function introduced nonlinearly into the modern, allowing it to learn complex patterns. Here are the most commonly used activation functions. Sigmoid. Sigmoid produce a smooth S-shaped curve. Output is between 0 to 1, o- often used in binary classification task. ReLU, rectified linear unit. Output is 0 uh, for negative input and the same as input for positive value. Very popular because it fast and reduce vanishing gradient. Third, tan, hyperbolic tangent, that is similar to sigmoid but range between -1 and 1, often used when you need a centered output. During backward propagation, we use the derivation of the function to calculate gradients, which help us update the weight effectively. Next, real world application. Now that you understand how backward propagation works, let's look at where it's used in real world life. Image recognition. From facial, from facial recognition in phone to identifying tumors in medical scans, natural language processing, NLP, uh, chatbots, voice like Alexa or Siri, autonomous system and recommendation engines. Self-driving cars use neural network to recognize road or obstacles. Platforms like YouTube and Netflix use it to recommend content tailored to your preference. Backward propagation is the brain behind this intelligence system. So, at the last summary, let's quick summarize everything we have covered. Multilayer backward propagation is essential for training deep learning models. It works by sending error signals backward and using gradient descent to minimize those errors. Each layer becomes smarter or time adjusting its weight and bias through feedback from the previous layer. The final result: a model that gets better and better at makes accurate prediction, whether its classification image, translating text, or powering autonomous machines. Backward propagation is a foundational concept where AI authenticates must understand. So thank you for watching my video. Bye.